Okay, so I'm starting my breadboard, which has the sensor already in it, and then I have my Arduino. So to start, we're gonna do ground to negative 5 volts into the positive, and then we're gonna go positive into VCC, and we're gonna do ground, which is in the negative, to ground, and then trig is going into pin 9, and pin 10 is gonna go into echo. Okay, so now that we have this is my circuit setup. I'm going to plug it in to the computer where I will explain the code. Hold on. I'm putting the sensor at 10. Okay, so now for the code. As I mentioned before, I defined the trig and echo pins, so I just did that in the code. I set up trig as the output, and it's pin 9, and I set up echo as the input, which is pin 10. The serial begins the starts the serial communication, and then I used pulse ln function to wait for the pin to go to high, which is produced from the bounce sound wave, and then low will stop the time. And then to get that distance from that time, we must multiply the duration by 0.034 and then divide by 2. And then at the end, I just printed the value of the distance. So I'm going to upload to the Arduino, and then I'm going to look at the serial monitor, which at the moment isn't going to be right because the sensor moved, but there. And as you can see, once I moved it to 10, it's producing 10. So from that, this number is what's getting printed from the serial print, and that number is the value that I explained earlier, which is gotten from the distance is derived from the duration multiplied by 0.034, and then finally divided by 2. And for the rest of the experiment, what I did was I just would move my computer back. I moved the sensor back so that it's at the correct distance. I hit serial monitor, and now I'm getting 20 because I just moved it back to 20. So that should be the same. Oh, it shifted again. There, now it's not shifting. So that is how I did that. As you can see, that's at 20, and then I just kept continually moving this back.